All right, hello, welcome back everyone. It's been a while since the last video. Um, Still trying to get my bearings a little bit. Um, Not what I was looking for. Okay. So, as is becoming a theme in these videos, time is actually very helpful for changing my mind over what should really be going on here. So this is a deployment diagram, not a use case diagram. So these two blocks that say uses seem really useless. Um, the uses arrows seem useless, and I think trying to capture this, I mean, this is really more of a use case diagram information. And I think that's part of what's complicating my deployment diagram and why it seems so crazy as I'm trying to like maintain this business over here. So I think I'm going to get rid of user and user device. And then, let's see, where is user device doing things here? Get rid of those. And then user device authenticates. Where are we saying that down here? There we go. Okay. So we can leave this external service for authorization. I think that's fine. Okay. Doorman, here's our overall platform. I think platform, maybe we can be a little bit more clear here and say the union platform. Union. And then identity and access management. Where in the world is that? Oh, you can put it in quotes. Okay, I like that. Doorman. There we go. And then platform, put it in colon or quotes. There we go. Platform is union, and then I don't need a title on this. Okay, that looks a little cleaner. Or actually, maybe I can say Doorman deployment diagram. There it is. Okay, Doorman deployment diagram. We have our platform, which is called Union, Identity and Access Management, which is Doorman, is these three pieces. We have a database wrapper for our user information, our session management information for authentication, and then all of our authorization information, role-based access control, policy-based access control, OIDC stuff, claim access, which I think says which users and which services have granted each other claim access. OIDC provider is our authentication provider, and then for authentication we have MFA, many instances for MFA microservices, right? So these microservices perform the MFA. Okay, and then we have our internal services relying party. Okay, one other thing that I would like to add is, well, maybe there's a couple things here, right? Okay, so I was a little quick on the database wrapper, right? I think we need a little bit more information about this, right? I'm talking about something that's incredibly hyperscalable. In fact, let me bring up the requirements again. Our overview. Okay, my requirements were millions of users, okay? this is not going to be a single database wrapper, especially if there are multiple authentication providers and instances of microservices. We're going to need multiple database wrappers available, right? So let's put in database. I'll just put this on the node, right? I can't put anything in there, can I? Okay, it'll have to be inside database. That's all right. Multiple instances. What's the difference between partitions and shards? I feel like that might be something I should know. I just want to know which one to use in my diagram. Sharding distributes a database across multiple servers, creating independent shards to scale horizontally, while partitioning divides data into logical segments within a single database system for performance optimization. Oh, okay. All right. Interesting. So we definitely want sharding. Okay. Which is interesting because they say partition tolerance is a failure of a partition. Okay, so let's use sharding here. It's my understanding that that's the correct one. And then naturally cap theorem is going to come in, right? It says on the local level, we have a database. We have some database interaction. We have multiple, we have to assume partition failure is going to happen. So consistency and availability, right? I think consistency is far more important to us since we're doing identity and access management. Availability is slightly less important, right? If an authentication or an authorization request fails, that can be repeated by the user, right? But we certainly don't want a situation where someone has logged out and then is still able to sign in on another device, or we don't want any sort of strange race conditions where there's inconsistent data and the authentication might have holes in it, right? I think a failure of inconsistent data on this database wrapper could be a lot more concerning than not necessarily responding to replies, right? So we are going to prioritize consistency over availability. And this is definitely going to mean something like writes take a lot longer, right? Well, you have to write to more of the nodes, and then you can read from any one of them. Maybe you have to read from all the nodes. Well, I guess that doesn't necessarily matter. You could design it in both ways, but essentially you need your writes and reads to. Oh, okay. The total nodes necessary for a read and the total nodes necessary for a write must be the sum must be greater than the total number of nodes. That way, there's at least one overlapping node between any read and any write. Yeah. Okay. Whew. Got to think back to my my school days for that kind of logic. Okay, I won't write that out in the diagram. That's a little intense, but and I won't call it. Yeah. So okay, there we go. That's important. Consistency over availability. This seems much more manageable, right? I really like this. And then you can have the external service here reaching out for authorization as well. Yeah, I like how this looks. This is clean. Okay, another thing I didn't want to talk about last time was load balancing, or what the front end looks like, right? So like our internal service wants to talk to our authentication provider. Okay, so anywhere where we have many instances of something, right? We're going to need a single endpoint that then distributes that traffic to the many instances. So I don't know that it's necessary to record that in the diagram, right? But like anytime we have something like this that says many instances, obviously we're going to need a single endpoint that other services can reach out to, and then whatever, you know, server receives that endpoint is going to have to distribute that traffic to the instances, not randomly, right, but accordingly, right, to maintain like communication tunnels and whatnot, right, but to balance the load, right? So obviously there would be some sort of load balancing on these types of services. I don't think I'm going to capture that in the diagram. That seems a little beyond what's really necessary here. I don't know that I'm gaining a lot by adding that to this deployment diagram. Okay, for authorization, trusted, or maybe Kubernetes has something built in for that I don't know about if it's inside. But we still have these external calls, right? So yeah, there'll be some business there. Okay, I actually really like this. I think this came out well. Okay, so those were changes that I wanted to make to my diagram. Let me grab the new diagram. And no, it's the overview. There we go. Nope. There we go. What? Here. There we go. I want to save the diagram. That's what I wanted. Okay. Deployment diagram is saved. That's good. And then let me also save it as a PNG again. Deployment diagram. That's what I wanted. Deployment diagram. There we go. Perfect. That's overwritten. Wait. Oh, it's deployment diagram png.png. Look at that. I was like, what's the difference here? Deployment diagram.png.png. Okay, so this is the old one. We want to get rid of that. And then this one, let's do that. Okay. And then here we go. Okay, this is the new one. All right, that came out well. I like that. Okay, now let's go back to the overview real quick. All right, so we have our MFA authentication methods. That was good. Access management service, requirements, single sign-ons, MFA authentication methods. Module. This is good. Schema, I'll put some work into that schema. That's probably fine still. Database wrapper, trust internal certificate authority, public-private key pair. APIs, create user, get user, delete user. Establish authentication session, verify authentication session, terminate authentication session. So the APIs here actually, so I'm going to add in all OIDC APIs, right? That's got to be the first thing. And then I don't know that we actually need this establish, verify, and terminate. I think that's kind of what OIDC APIs do. So I'm just going to have that. Oh, wait, you know what? I don't know that OIDC has a termination, right? We didn't talk about that. Terminate the authentication session. So this will be like our single log off. Okay, the service server, the relying party. We don't really need any of this. We just need the OID relying party APIs. Boom. Okay. Orchestrator. Okay. Diagrams for use cases. See, this is where authentication seems. Oh, I needed new database schemas for session management information. Yes. Okay. Yeah, so we're going to need something like start session, username device, right? Name device, and then terminate session. Maybe end. Keep in line. Start session, end session. And then, yeah, we're essentially going to need a. Okay, so this was like the different users. Okay, so let's say this is. Oh, I already have a user session information database. Let's do that. Session database. So really, it's okay. Let's say we have user table here, and then let's just call this the information database. We have a user table, and then let's have a session table. I think that's a little bit more close to what we would be doing here. Okay, and then we have a session table where you have the user ID number. Oh, you know what? You might actually want an ID of a session, right? ID, session ID. Okay, and then the user ID, which is, what do they call that, a foreign key? All right. Probably don't need the username. We could just look it up. Personal information, any of that business. We need the device. Ooh, we don't have like a. Should devices be kept in a separate table? And then we have our authentication device. Yeah. That would be easy. That would be easy. All right, you know what? Let's just add a device table that we can reference here. Device. Device ID, and then, I don't know, device information. Like MAC address or something. I don't know what information we really need on the device, but we'll see. Oh, and then maybe the public key for the device is. Yeah, I don't know if we want to go too far down that route. Because a device might have. Do we have a device associated with multiple users? In which case, does it have multiple private keys, one for each user, or? All right, yeah, let's not overthink this device information. Let's just create our device table that we need. Let's say we just have a device ID and a MAC address, and then here the session table is just a device, a user ID and a device ID, also foreign key. And then here we can put key. Probably should have put that on all the other ones. All right. Beautiful. All right, so there's our session table, and then we to create a session and end a session, and then we needed one more thing, which was our authentication information. And you know what? I don't know how rigorous we need to be there, right? But like our authorization table, Um, RBAC, PBAC seems a little like a little difficult, but I like the idea of OIDC claim access. That seems actually really straightforward to me, right? You can have a junction table, which I guess is kind of what this is, right? Isn't that correct? Let me write it out and then I'll double check here that this is a junction table. Okay. Composite primary key. Composite primary key. Look at that. Yep, students. A classroom ID and student ID. Primary key is a junction. Time. What was start time? There you go. Also going to want to have a start time for the session. Okay, authorization table. We're going to need a cool session ID. Composite key. Cool. Okay, and then the authorization table. So the idea that I have here is the user will have some sort of authorization agreement with a particular service, right? So the user will want to use a service, the service will want to allow the user in, and they'll have to agree to work with each other, and that'll create a record in some sort of junction table. So what we really need is a service table. With like a service ID, right? So all of our services get a table here. And then I won't think too deeply about that. And then we'll have a authorization table. Again, junction table. Or maybe let's call this the claims table. Claims table. Claim ID is a composite key of the user ID and the service ID. And then it'll also have, which claims are supported. Would it make sense to have a claims table? All the different types of claims that are allowed? I guess for all the different information that could be shared, because that's really what we mean by a claim, right? It's information that can be shared. Okay, there's two different things here that I'm conflating, and I didn't realize this before, but I want to be clear about it, right? So the OIDC claim access is authorizing which information the service can get from the user, but the role-based access and policy-based access control are determining the functionality that the user can do on the service. So those are two very different things. All right. So let's try and be a little bit more clear here, because I think I'm kind of throwing this around. We want a claims table. Yeah. And let's create an access table. These are two very different things, right? Okay. So the access table, the point of this is to for RBAC, which users can use each service and to what degree, right? Okay, so this actually seems quite simple to me. I don't know if it should be, or maybe I'm simplifying it, but you could have a roles table because you might have different roles for different services, but you might have the same roles across services, right? So I don't know if you want to call this a role or a policy or what, but we're just saying like there's a group of people. We can call it a groups table. I'm going to call it a roles table, and it has like a role ID, right? And maybe a description or something, right? And then you're going to have a user roles table, right? Which is a junction table with a composite key. That shows which roles, and this will show which roles a user has, right? Okay, the user role ID is a composite key. So using this table, you could see which roles the user has. And then the access table will show like, this will be the junction table between, maybe I'm overusing junction tables here. Okay. Which users can use which services? Oh, man, but then do we also have to say what a particular role means for each service? We just need which roles can use which services. But if there's different levels of access, no. Okay. No, I got it. Okay. Then there's a role service. The role ID and user ID. No, and service ID. Okay, I need a couple of these foreign IDs here. We need role, service, and then here we need user and role. Okay, so the idea being, user comes in, wants to use a particular service. What we're going to do is we're going to go to the user roles table and find all the roles that this user is in. I like groups more than roles. Does groups make more sense? I'm gonna say groups because a user really doesn't have multiple roles. I don't know. Wait, what? The world just happened. Okay. Did not mean to do that. Okay, so there'll be the group table with a group ID. I like this more. Group. We'll call this access ID. User group. Okay, so we get a user, we go and check where that user falls, which groups that user is a part of using this junction table, and then we take those group IDs and we see what access that those groups have to different services. And if there's any overlap where a group overlaps with the service, we're in business. Group. Okay, so that handles that. Is this what policy-based access is instead of role-based access? Okay, we're gonna have to put it off. Okay. Policies to grant. are assigned to roles, and users are then assigned to those roles. Okay, so this is role-based access. I'm just using the term groups, which I think makes more sense, at least right now. All right, now we have to deal with the claims table, which is the other way. It's what the services get from the users, and it's going to be very similar, right? So what we need is yeah, okay. What we need is a claims table, which is not a junction table. It just has information fields, right? And this is basically saying this claim means that this information just represents this information, and then what we have is like a three-way junction table, which I'm sure must be possible. We'll call this the OIDC claim access table, junction table, and what we'll say is there is a OIDC claim ID, which is composite key of user ID. So it's this user this service and claim. There you go. The composite ID of a user ID, service ID, and claim ID. So you find, and so a service will ask to use a specific thing, or a service will ask for a specific piece of information from the user. We will find that information field in the claims table, and then we know we're looking for this specific user ID, service ID, claim ID composite key in the OIDC claim access table. And then I'm just going to copy down these foreign keys and have user, service, claim. All right. Got a little confusing there, but I think this went well. And then I'm going to get rid of PBAC here. I'll leave it, but RBAC is what I implemented. Okay, so we got the databases done. That was important. Start session, start session, end session, and then oh, you know what? Instead of OIDC access, what about permissions? That's a good term for what we're doing here. Permissions table, and then permission ID. And then I could see something like username, service, info, information field. And then something like has permission. And this is checking if the service has permission to get this information field from this user. And then there might be another one of like, oh, give permission. Right, same thing. Okay, and then remove permission. There we go. And then we need to discuss this last thing, which is the RBAC. So we should probably add user2 group. And it's user group. Also probably have to create and delete groups. Let's see, create group. I don't know, group info. Group name. And then delete group. And then we have add user to group, remove user from group. Perfect. And then we need to give group um, uh, access to service. Maybe access table has other auth information. It might be application dependent to a certain degree. Other authorization information. And let's say that that's just passed along in here, right? What we want is group service give access. And then we'll need has access and remove access. Has access. And I like to think other authorization information is what's returned, right, for group and service, and then remove access. Remove access. Ooh, and then there might be like a change access, since we're saying that there's like levels to this, right? So there might be a change access where we update the other authorization information. Boom. Okay. And then we can probably separate these a little bit, like there's user APIs, session APIs, RBAC APIs, and then OIDC claim APIs. I'll just say claim, maybe permission APIs. There you go. All right, important. Okay, I think the overview is now a lot more complete. Handled this schema. Okay, I'm not going to create a diagram for the authentication use case. I am instead going to go get that OIDC diagram that I've been seeing around. Nope, this is a company sponsored result. This is what I want. OpenID Connect. How does it work? Now, there was a good thing in the documentation. Specifications. Where's the actual? Here we go. OpenID Connect specifications. OpenID Connect core. This is what it is. Here we go. This diagram. This diagram is phenomenal. Okay, and you know what? I will not do the disservice of copying and pasting from this beautiful documentation. I will simply copy the link and allow other people to go look at it. Okay, so authentication, we're going to say that's been cleared. Okay, single sign-off, I don't think is identified with OIDC. Or is this what high-level OIDC was? See, I don't know about either of those. Okay, single log off. This is interesting, right? This is something I have not discussed, but I talked about the idea of sending an event to log out. It can't really be an event, as in a notification that's just sent out. What we need is we need the service to respond that the logout has occurred successfully. Not just that it's received the application, right? But what we need is like the user comes to the authentication provider, clicks logout, or the user sends a logout request to the authentication provider. We end the session, but then we are going to reach out to every service that the user is currently logged into. Which means we need to be keeping track of which user devices have sessions ongoing with which services. Yeah, that's what I didn't get here. We need a start service session and end service session. And we need a table up here that shows, okay, these are the ongoing sessions and these are the ongoing services. We have a service session table that has is a junction table, service ID, session ID. A session ID, we'll just say foreign key, and then the service ID. There you go. Okay, we need that. And then single log off, we could theoretically go in and see get service sessions username device. And this will give us all the services that this user and device combination are currently logged into, and we can log out on all of them. Genius. Okay, so the question is, the authentication provider receives, understands somehow that the user wants to end all their sessions. It goes to the database and it figures out all the services currently running, and then does it reach out to all of the services? Yeah. So maybe what we really want is some other microservice or some other node running that reaches out to all these other services and gets them to log out. I guess the authentication provider directly could do it. We already have many instances. I don't see a reason to separate out that into another node the way I did with MFA. Yeah. All right. In that case, the authentication provider will just reach out to all the services and ask them to terminate a particular service, and they'll either say yes or no and tell the user it either succeeded or failed. Or which services failed to log out. We could retry a couple times too, be a little more robust. All right. So I don't know that I actually want to create a use case diagram for a single log off. It seems actually pretty straightforward. Would look a lot like my deployment diagram. So I don't think I will. Let's see. Responsibilities ended up using this standard. Boom, IDC. Okay, and then I think that takes care of this. Beautiful. Beautiful. Okay, so I think these three are the real outputs. Okay, so only one diagram for a system design, and I don't know how many hours this was, probably only 6 or 7. I will say I learned a lot about, I learned a ton about the kind of history of authentication, both over the web and just, on networks where there's a non-trusted party in between, right? So a lot about Kerberos, a lot about SAML, and then a lot about OIDC. Super interesting. I'm going to put all this up on the GitHub, and then It'll be available. We might have to revisit this in the future, right? I have a feeling that like as the series continues and I create more services for Union, right, that do other things, um, the requirements on the identity on Doorman are going to be kind of changing and increasing, and I may need to revisit this design. But for now, it's so simple. I don't know why they struggle for this. No, I'm kidding. It seems like it makes sense that this industry is massive identity and access management, and why so many people choose to do it in house, and why so many people choose to use one of these as existing third parties. Chaos. All in the name of security. All right. Um, Thank you, everyone. Appreciate your time. Uh, uh, yeah, thank you.